Hello, everyone. This is Randy Johnson, and I'd like to welcome you to this session of the 2020 Vectric Worldwide User Group meeting. I'd also like to extend a special thank you to the Vectric team and the folks at Nextwave CNC for inviting me to be part of this year's meeting. It's always been a gathering that I've looked forward to. The project I settled on for this session is the two-sided textured bowl that you see in front of you. Two-sided projects and texturing have been an interest of mine going back several years. In fact, I first used the techniques in some articles that I wrote when I was the editor of American Woodworker magazine back in 2012. On the left side, you see an oval bowl here where I used the two-sided technique on both sides of the bowl. And here are some two-sided lids with some texturing on them. Back in 2012, the double-sided setup in VCarve was not available, and one had to set up two separate files and do the indexing separately. It still worked fine, but it sure has been convenient to have the double-sided setup right in the program right now, where you can see your vectors on both sides of the shape at the same time, as well as set up toolpaths for the two sides. For today's project, the top of the bowl, a close-up here of the preview look of it, I'm using the toolpath, the texturing toolpath to create some triangular shapes inside the bowl. As you'll notice, the texture travels all points towards the middle. And I'm able to do that, I'll show you later, by angling the texture toolpath. I also have vectors that represent the triangle for each one of these sections. On the bottom of the bowl, I've added some curved lines to create a spiral design, as well as the foot and some lettering on the bottom of the project. So those are the things that we'll look at today. The material that I'm using is a block of hardwood. I tried both cherry, walnut, and maple, and they all carved well. This is a block of maple here in front. I thought I'd challenge myself a little and see how much of this I could do in VCarve Desktop. And it turns out I was able to do it entirely in VCarve Desktop. There's a few tricks along the way, and I will show you those. But VCarve Desktop, even though it's the entry-level VCarve program, the modeling aspects, the clip art, the toolpaths that Vectric have added to this program has actually made it a very powerful program for the entry-level VCarve. So create a new file. In the setup, the first thing you need to do, of course, is set up a double-sided project. So you have side 1 and side 2. Job size, I'm going to set this at 9 by 9 by 2. The 2 represents the thickness of the block of material, but the 9 by 9 is a little larger than the actual block. And that gives me some room for tool pathing and some design work that I'll show you later on. On the Z0 position, I'm setting up to the material surface, which means when I cut the top of the bowl, I'm going to zero to the top, but I also check the box for zero off the same side. So when I flip the bowl over, I'm still going to zero off the same side, being the top of the bowl, but now it will be the machine bed. This provides the exact reference from the top of the bowl, whether I'm cutting from the top or with it upside down. For the XY datum in this project, I'm selecting the middle of the material, and I'm going to do a forward to back flip direction. Everything looks good. The first vectors that need to be created are some very basic vectors: an inside vector for the inside of the bowl, a circle for the outside of the bowl, as well as a vector that represents the actual block of the wood. Having created the outside circle, that actually represents the diameter of the bottom of the bowl. So I'm going to right-click and move this vector to the other side of the project. When you move a vector to the other side of the project, it appears as a light blue line. In this case, this blue line is on the bottom side of the project, and we're looking at the top side of the project. You cannot select this line or work with it in any way, but it does give you the ghost image to show you its location. Very handy feature. The boundary line for the block of material, I'm going to copy that to the other side because I'll be using that on both sides of the material. So I set it up for a copy to other side. We're now ready to import or use some of the clip art that comes as part of VCarve. So I'm going to click on the clip art tab, scroll down to the clip art to the domes and dishes, and I'm going to select the first dome shape, double click on it, and that will insert it into the drawing area. It's not the right diameter, the right thickness, so we need to modify it. To do that, I will then go to the modeling tab at the bottom. We can see the dome and dish appearing in our list. I'm going to open up the properties window for this model. I'm going to rename it Bowl Inside, so I know what model it is. I'm going to switch the combine mode to subtract because we want it to be a convex shape, or rather a concave shape. But it changed the shape height to 1.5 because that's the dimension that I've determined I want for this bowl. Looks good, we'll move on. And now I need to increase the diameter of the model. So I'm going to switch over to my drawing tab, open up the set size window, and I want to increase this model to 7.25 inches to that outer line that I created earlier. So to do that, I'm going to link XY, enter 7.25 for the dimension, but I'm going to uncheck the auto scale Z because I don't want the 1.5 inch height that I entered earlier to be changed. Hit apply, and now that model matches the diameter of the inner circle that I created. We take a look at the 3D view. You can see the dish shape for the bowl inside. We now want to take that model, right click, and copy it to the other side. So we then go up to the top of the menu, click on toggle to the bottom side. When the bottom side is showing, the rulers show up as yellow as a visual clue to let you know you're on the bottom side. And you also see the arrow pointing to the bottom side up here in the icon, give you a clue as to which side you're working on. We're going to switch over to the modeling tab, select the model. It currently says bowl inside, but we're actually working on the bottom side. So I'm going to go into the properties window, change the name to bowl bottom, and we're going to change the combine mode to merge. We now want the shape of this height to be 1.75 inches. So we change that in the properties window and hit close. Next, we need to go back to the drawing tab because we want this model to be the diameter of the circle for the drawing bottom. So we open up the set size window again. Same settings as we had before, except we're going to change the size to 7.75 and hit apply. And that increases the size of the model to 7.75 while still maintaining the original height of 1.75. We can close that. Let's take a look at the 3D view. We can now see that our bottom dome and our top dish are combining to create the shape for the basic shape for our bowl. Next, we need to add the foot. To add the foot, we're going to go back to the clip art. Underneath the same dome dish menu, we have an item called flat round circle. So double click on that, and that inserts that basic shape. Now it's showing up green because it's hidden underneath the existing dome. And we'll change the size and bring it up to the shape we want. So I'm going to click on the modeling tab, and there we see our flat round circle. Back to properties window, change the name to foot, change combine mode to merge. We're going to use the same height for the foot as we used for the bottom dome. So it'll be right there, the same height. We can hit close. And now you see foot appearing in the menu. Go back to the drawing tab. Back again to the set size window. And once again now we can modify. We're going to link the XY. We don't want the auto scale feature. We want that turned off. The diameter for the foot is 3.25, so we enter that and click apply. We now have our foot inserted. The final bit of modeling we need to do is add some 3D tabs. This is not to be confused with the 3D tab you set up in the toolpath. We'll be using those later on. But right now, underneath the clip art, there's a section called 3D tabs. At the very bottom, I'm using the one called truncated. It just inserts a little tab in the middle. You can drag that out to the side. You see it looks just like a little brick. That can be rotated and modified. And in this case, I put it at an angle at the corner. I stretched it and made it wider. I'm also going to open up the properties window and change the thickness to an inch, rather to 0.125. I've also created 4 of them all the way around each position, and they just merge right with the existing dish, and the list of those tabs show up in the list. The modeling is now complete, and now it's time to set up some of the vectors. So the first thing we're going to do is set up these pie shapes, which represent the area for the textured carving in the top of the bowl. So we're in the top view right now. To start with, I'm going to select the circle that we've created for the inner bowl. I'm going to select the offset tool and offset by 1/8 of an inch inward. That creates the new vector. Close out of that. Now you want to make sure that your toggle geometry snapping on-off is actually turned on. And you know that this tool is turned on. Any 3 of these tools, you can see they're turned on when they're highlighted light blue and there's a little blue line around them. The 2 at the right here are currently turned off, whereas I have toggled the geometry snapping one on. And that'll help us lay out the lines for the pie shape. So go over and select your line tool. And it's using the snap tool makes layout of very easy and precise. And here's the basic steps. You snap and left click to anchor it, drag it into the middle, snap it again to the middle of the drawing, left click, drag it down here. Again, you'll get a snap point, left click to anchor it, and then right click to end the creation of the line. You now have the basic shape for one of the pies. We're now going to go in and get the trim tool. And we're going to trim out all the way up, all these little lines right here, all the way up to this inner circle. This one and that one. So you're going to snip those off. They've all been removed. And the last one we need to trim off is the outer part of this inner circle right up to the side of the pie shape. So you can snip that off. And now all we're left with is our primary pie shape. We can close this trim tool. Next, we're going to go down and get our offset tool. Select that pie shape. And we're going to offset inward 1/8 of an inch. We're going to delete the original, and select the new one. So click offset. We now have our new offset. And actually, I erred there. The original did not delete, so we still have it. I can close. Now we're going to select our new offset shape. The new pie shape should be automatically selected. We're going to go into the circular copy tool. First thing we're going to take and move the rotational center to 0, 0. So it's at the very middle of our shape. And you can see the little circle there, double circle that represents the rotational center. We're going to rotate the copies. We want 8 of them, and we want to do a total angle of 360. So it rotates them all the way around, and we do not want them grouped. So we hit copy, and we now have our new copies all the way around. And we can exit the circular copy tool. You now see that we have nice, even, same size borders between the pie shapes as well as from the edge of the bowl. Our original vector can now be deleted. Those are the vectors for the top of the bowl. We're now going to switch back to the bottom of the bowl. At the bottom of the bowl, I've created a series of arcs, again, using the same kind of snap, trim, and array copy, circular array copy to create the same arc all the way around. So it's the same principle of creating this array, the circular array, as we just used in the previous top side of the bowl. These lines, of course, will be used for the cutting on the bottom part of the bowl. Next, we need to add an inner circle to the foot. This inner circle vector is going to be used both to align the text as well as create the inset on the foot when we do the tool pathing. The last vectors that we need to add are the pegs or the registration holes. We're back at the top side of the project now because we will be drilling holes in the top side of the project, which we then will flip over onto the table. So I've created the 2 peg holes or registration holes. I'm now going to copy those to the other side. So we'll be using those on the other side of the project as well. We look at the bottom, we now see the registration hole showing up on the bottom side of the drawing. These won't actually be cut in the block. These holes will actually be cut in the table to receive the pegs, and we'll see that later, how that is set up. We can now go back to the top side, and we're going to go over and open up the toolpath panel and start creating toolpaths for our project. First thing you want to do when you're working with models, and you've set up your models, especially a 2-sided model, but even a single-sided model, is you want to go into the material setup when you're over the toolpaths, and you want to verify that the position of your model is where you want it. The model, which in this case is 1.75 inches thick, which is what we want, is represented by this light tan area. We want that to the top of the model. And we want any gap to the bottom of the model because we want any variation or waste going to the bottom of the model because that'll be the last part we cut. And everything is being referenced off the top of the model. So with that set up, we can take a look at our material. And one thing I noticed about several of the blocks that I had, they were flat on one side, but the other side had not fully been surfaced or planed, and so many of them had a slight gap at the top. But this doesn't create too big a problem. I just have to create a toolpath to deal with it. But first, to show you how I attach the material to the table, I use these little blocks of plywood with hot melt glue and glue it to the corner, then screw it down to the table. They're very handy. They break off with a little bit of force, so you can reuse them on both sides. It's very convenient to use these when you don't want to put screws to the block or have big clamps going on. You do need a spoil board to screw to or attach to, although you could also use hold-down clamps right on top of these as well. Again, whatever works to keep the project from moving during milling, that's what matters. So we're going to create a surfacing path to take and surface the top of this block. If your material is perfectly flat, that's fine, but most blocks may have a little variation. So it's always a good idea to create a little surfacing toolpath. Using the pocketing toolpath, I'm selecting the vector that represents the block of wood. Let's take a look what the toolpath looks like. Notice up here that I've set it at a 0 cut depth. And that's because I have very little wood to cut off, and I'm actually going to zero my first setup to the low spot on the top of the material. Then as the router bit passes back and forth, it's going to cut off the high area. And for this block, it's not much more than a 1/16 of an inch. So it's still too much unevenness. I don't want to leave it this way, but it's a small amount to take off. So in one quick pass, it'll take off all the top and make it smooth. So having surfaced the top, all future zeroing now for the top toolpaths will be zeroed off the top of this new surface. My block now is slightly less than 2 inches, but that's okay because my model, as you remember, is 1 3/4 inches. So as long as my block ends up greater than 1 3/4 inches, I'm not going to have a problem with the machining along the way because any variation is going to end up below the feet. So the first tool path for the top of the bowl is going to be the roughing tool path. And I'm going to use that inner vector. I've got it set up for select vectors. So I've selected that inner circle we created earlier. That keeps the roughing tool path inside the bowl. I'm using the Z level. Either one works well. The Z level is a little quicker. And I found that when I go back with my finishing tool path, these little ridges, which are about 1/10 of an inch high, didn't create any problem for the 1/4 inch ball nose that I then used to machine the finishing tool path. So for the finishing tool path, as I mentioned, I'm using a 1/4 inch ball nose. I use the same vector to keep it inside the bowl. You can see how much closer the tool path pattern is. I used a 9% step over for this 1/4 inch bit. It left me with a little bit of sanding, but it worked well. Now that I have the inside of the bowl carved out, I'm now going to add the texturing tool path. And to do that, I'm going to select my first pie shape. Here you can see the settings that I have. They're kind of average settings down the middle, and it worked well for this project. But my angle is the one setting I need to take a special look at. For this one, I set it at 22.5. That way it runs directly down the middle of the pie shape towards the middle of the bowl. I'm then going to check the box for project toolpath on the 3D model and give it a name and call it texture 1. We now have our first pie shape or triangular shape of texture. It's showing up in our toolpath. I'm going to right click, which brings up the local menu, and I can duplicate that toolpath. And then I can double click on that to open it. And all the same parameters show up. Now inside the angle box, if you add the plus sign, 45, and the equal sign, it will automatically calculate what we need for the new angle for this project, which is 67.5. I then select the new vector for the next triangle, and then rename it texture 2 and hit calculate. And I now have my second section, and it's all rotating around the center of the project with the toolpath going in the direction I want it to go. So again, I right click, duplicate, open up this duplicate toolpath. Again, I simply add 45 to the previous dimension degrees, giving me 112.5. I select the third pie shape, rename it texture 3, and hit calculate. And you continue this pattern of duplication and calculation and adding the 45 degrees until you have all 8 toolpaths created. This is also a convenient place to use the grouping function. So if you right click, you'll get the local menu and it says group visible, and anything with a checkbox in it is visible. So when I hit group visible, I now create a group of those toolpaths. I've renamed it bowl 04 texture. And if I hit the minus sign to the left here, it then shrinks it down into the primary tool path. And if I save this out, when I go to save my toolpaths, it will save out all those that are underneath it. That's what the texturing looks like on the table of the machine. The final toolpath that we need to create is for the registration holes. Because registration holes are going to 2 quarters of the project. I'm using 1/2-inch dowels for this. The dowels are about 1 inch long. So I'm going to cut my hole about 3/4 of an inch deep so I have plenty of clearance for the dowel, using a 1/4-inch end mill. I like to use the profile toolpath for cutting holes. Don't really call it drilling, it's really cutting. It's much quicker than, or I find it more convenient than using the drilling toolpath. And I also use the spiral ramp, and it creates a corkscrew type shape of the toolpath. It's very efficient. The router bit just kind of corkscrews its way down to the bottom and comes out, gives a nice clear cut with the chips coming out of the hole. A lot of you I know use that as well. And if you haven't tried the spiral toolpath for cutting your holes, you should try it because it works really well. You just need to make sure that your router bit is at least as large as the radius of the hole. So my hole in this case is a 1/2-inch diameter. My router bit's a 1/4 inch. We now have all of the toolpaths created for the top side of the bowl. And we can now switch to the bottom side of the bowl to create the toolpaths for that. Again, we need to remember that on the bottom side, the Z0 position is on the bed of the machine. And you can even see it in the material setup window. It's showing you Z0 is on the bottom because we are on the bottom view. We are in the bottom view of the project right now. These are the toolpaths that I've set up for the bottom, and we'll take a look at these. The first one, the registration holes, actually need to go in the deck of the material, which means they have to go below the material. So in this case, I set up a start depth of 2 inches, which is the surface of the bed of the material, and then cut into the spoil board 3/4 of an inch. Again, I used the spiral setup to cut these holes and then added my dowels into the table. And then flipped my board over and lowered it onto the dowels. You don't want the dowels to be too tight in the holes. In fact, you don't want to have to hammer them in. I find personally that I like to be able to push them in, put them in and put them out with my fingers. If they're any tighter than that, I've actually had difficulty aligning it because the machine cuts them so precise. So the next toolpath at the bottom of the bowl is something I call the thickness clearance. I'm using a straight bit with a 1-inch cutting depth, and since my block is 2 inches thick, there's a couple spots in the corner where the collet wanted to hit the remaining material if I didn't remove it first. So if you're using a longer bit, or especially if your machine takes a 1/2-inch collet, you're able to cut a deeper with the longer bit. Otherwise, this clearance makes sense. For the roughing toolpath on the 3D model, its setup is very similar, the same as the top side, and you can see here what it looks like. Again, I'm maintaining it within the circle that represents the outside of the shape. However, I did set up a boundary offset of a 1/2 inch, so it oversteps that line a little bit. Now, this shows you why I did the job setup at 9 inches versus the block, which is only 8 inches. As you can see at the top here, the toolpath will only go to the edge of the model or the edge of the job setup. And there's not enough room for the 1/2-inch bit to go between the edge of the project block and the model itself. So by adding that extra space, it allows the router bit to pass all the way around the model. Otherwise, it would have left a chunk of uncut material along the edges, these 4 edges of the bowl. Finishing toolpath, again, it uses the same outer vector, same setup we use for the inside. The spiral design on the bottom, I'm using a 1/4 inch ball nose to cut that. I'm cutting fairly shallow, only 0.03 deep, cutting on the line and adding a ramp to ease it into the material. Doing the inset or the recessed foot, here's the trick. You can't model that in VCarve. However, if you turn the foot model off, create another finishing toolpath, and select that circular vector, that toolpath will then project itself onto the original dish shape. And in the actual finished project, it will cut out on the inside area. So it's kind of a workaround for not being actually able to model that rig, which you could do in Aspire very easily. But it gives you a recessed foot, even though you had a solid foot in the model. The same applies to the text. I'm leaving the foot model turned off. I'm taking the V-carving, selecting the project toolpath to 3D model, and it now applies it to that surface that we just cut for the recessed foot. The final toolpath involves the cutout, and for the cutout, I'm using the profile toolpath. Since I have so little material left at the bottom here, I'm doing a start depth of 1.875 or 1 7/8 inches. That's my tabs are 1/8 inch thick. And then I'm going to do a cut depth of an 1/8 inch, which will just cut through the thickness of my final material that's left there. Using a 1/4 inch bit, I'm going to go on the line, which is going to give me a little bit of a shoulder and kind of cut off the knife edge on the edge of the dish itself. Also going to add some regular tabs. Length or width is going to be 1 inch with a thickness of 1/8 of an inch. And I'm going to put those tabs right on top of the 3D model tabs. You see them right here, the little yellow spots. Those are my toolpath tabs. And you can see down at the bottom when it's cut out of the toolpath tab, which I use what's called a 3D toolpath tab, is remaining. And here's a close-up of the actual project. You can see the 3D toolpath tab as well as the 3D model tab behind it. It leaves just a very little bit of material to clean up. Again, the 3D model tab is on the shoulder right here. This is the 3D toolpath tab. You can see the little flat edge that the cutout left for a little shoulder. I then took some sanding and sanded that edge over nice and round for my final projects. As I mentioned, I tried this in walnut, cherry, and maple, and they all worked very well. There were a couple things along the way, though, that I learned, again, and I'm sure you can all relate to these. But the first one is that wood moves. And if you've ever done wood turning on a lathe and created a bowl, when you remove the amount of material you remove it from the inside and the inside tension, whether the wood is green or wet or moist or just the inside tension of the wood, it's very common for the bowl shape to move. And on one of the walnut bowls that I carved, I discovered this because the bowl shape itself turned a little bit oblong and it went deeper on one side than the other. So the workaround for this is when I did my maple dish, I let the dish set a couple of days and let it stabilize, and then went back. I let it stabilize after I did my roughing toolpath on the bottom. And then I went back and did my finishing toolpath and then did my spiral design. And then it actually worked out quite well. So do be aware that depending on the moisture content of the wood or even just the grain of the wood, you may occasionally get a bowl that moves a lot, like I did on this walnut one. The others I cut worked quite well. In fact, I had one that didn't move at all. But wood moves, and that's a lesson that part of working with wood. The second one, CNC specific, and I can hear you all chuckling out there right now because we've all been there. And this one was particularly kind of embarrassing because I had the neighbor kids over watching me, and they were totally enamored by watching the bowl being cut. And I was bragging about how I was down to my last cut, and they were going to be able to hold the bowl. And when it went up through there, they said, "Randy, is it supposed to do that?" And I made up some joke about this being the spot where I'm going to hold my spoon. But they thought it was kind of funny when I told them what happened. Anyway, double checking your Z is always a good thing. And this is I enjoyed making this project. I hope you're able to give it a try. And it's a great project to practice the double-sided machining and adding some texture in. I want to thank you for taking the time to be part of this session. And I hope you're enjoying all the other sessions as well. Have a good day.